Shalom and welcome to everybody. So nice to have you with us here for our third session today, which will deal about propagation and cultivation of forest trees. And I think I will give the mic to Shani and let's go into subject directly.
Hello, everyone. Already our third meeting in this series of webinar. So for those of you who are here at the first time, I'm Shani Roatin from KKL-JNF, the Forest Service of Israel. And I'm responsible on research and foreign relations. And it's my pleasure to introduce today Hagay Yavlovich, our head of seed and nursery division at KKL-JNF. Here, Hagay, just near me. Hagay holds a master's degree in agriculture and is certified agronomist, and he began his professional journey as a forester in the field and has been working in KKL for the past 17 years. So a lot of knowledge he gained and he will share with us today. And wishing you all enjoyable and successful lecture.
Okay. Yeah. Patient. Okay.
Just to say, if you have a question during the lecture, you can write in the chat, and in the end, we will have time for discussion.
Shani, do you see the presentation? Everything is okay?
Yeah.
Okay, great. So, good morning, good afternoon, good evening to everybody, each one in his own country. Really happy to be here with you and to share with you my knowledge about propagation and cultivation of forest trees. My name is Hagay Yavlovich. I'm the director of the seed and nursery department, and we will talk today about propagation, as I said before, and we will talk a lot about seeds and so on. And let's go on to the journey. So a little bit, one slide about me and what we are doing in the seed and nursery department. And this is like a small or one slide that actually summarize a lot of our job. And actually, okay, the seed and nursery department, we provide propagation materials and material to the nursery, to the KKL nurseries. We have 3 nurseries here in the KKL, and we're responsible to collections of seeds for something like 250 plants and many species like conifers and insidious trees and natural broadleaves, eucalyptuses, shrubs, and more. Many kinds of species. We collect the fruits all over Israel, all over the country, and we bring them to the seed center. In the seed center, we extract the seeds from the fruit, okay, and we storage them in the refrigerator room, and then we transfer the seed to the nurseries. And of course, in the nurseries, we grow the trees, and then we plant them in the forest for the next generation to get the best tree in the forest. This is one summary of what we're actually doing. And we also deal with mechanization and some other agricultures and things in the nurseries, but this is for other lectures. Let's continue. Okay, so actually I think that all of us, we want to take and make such an area that have no trees to something like this, to something that has a lot of trees. And for this we need trees, of course. We need good trees, and we need to to start with high quality source. You must to have very good start, and sometimes people forget about it and they just plant trees and they forget the source. They forget that you must have a good quality. You must have good begin if you want to get at the end a good tree. How are forest trees produced? So, like most forest trees nurseries in the world, the main source of propagation materials in the KKL are seeds. So let's talk about a little bit about the lecture topics and what we will speak about here in the lecture. We will speak about propagation from seeds, why, what's the advantages and the disadvantages. We will talk about how we locating the mother trees. That means the trees from we collect the trees, the seeds. We will speak just a little bit about introducing and tree improvement. I mean, to bring new trees to your countries, trees that are not natives, why and how, and a little bit about tree improvement. That means how to take to find or to do something active for finding a good source for seeds. And we will speak about fruit collection method, how to do it. We will speak about how to extract seeds from the fruit, how actually to do it. About seed storage, pre-germination treatment. It's very important. Sometimes people forget to do it, and then you just like you saw a stone. Because if you don't make the pre-germination treatment, the seed will not germinate. And we will speak about germination method, and I hope we will have enough time because it's many things, many topics. Okay, let's start. So to understand it, we must at the beginning to understand that there is a big difference between sexual propagation to asexual propagation. When we speak about seeds, seeds are sexual propagation. That means that what you get in your offsprings, there will be traits that are uneven. One will be shorter and one will be taller. One will be stronger and one will be weaker. This is something that we want in our forest. We want that the forest will be diverse. Because if the forest will be diverse, it will be stronger. It's good for us. And this is the sexual propagation. The asexual propagation, that's mean the cuttings, the grafting, tissue culture. Okay, and in this option of propagation, all the offspring will be the same, actually the same, and all of them will be will have the same traits like the mother, like the trees that the branch that the trees that the branch what was taken from. So all the offspring will be the same. This is like in orchards. Okay, so in orchards, you want all the trees will be the same. This is good for orchards, but it's less good for forest, because if some insect or something will attack the forest, so all the trees will die. So this is why we prefer our forest to be made from seeds. And we can see that here in this table, okay, that there are many differences between the sexual propagation and the asexual propagation. If we will take the right side of the table in the sexual propagation, okay, so sexual propagation, as we said before, it's from seeds, and relatively it's cheap. It's cheaper than grafting or rooting and so on. Relatively easy. working with seeds than with grafting and rooting and so on. As I said before, you accept genetic variation. Each one of the offspring will be different. It will take time until you get maturity. It means that the offspring are juvenile at the start, and it takes time to become older and so on. And this is like the opposite between the asexual propagation, that you got a physiological mature plant at the minute that you got your new tree. And you must remember that sometimes you have germination difficulties. Sometimes you want to make sexual propagation, but it's very difficult to germinate this kind of species. Sometimes there is seed storage shortage. Sorry. So you want to make propagation from seeds, but there are no seeds. And if we take the left side, so asexual propagation is from any origin in the plant except flower or fruit. It's more expensive than seed. It's required knowledge and skills to do it. You need to know how and when, and you need equipment that's more expensive than working with seeds. And as I said before, all the offspring are the same in genetically, and of course there are also rooting difficulties from time to time, and sometimes when you want to do the rooting, most of the time you look for the juvenile part of the tree to make the rooting, and in some trees you don't have the juvenile area or the juvenile part to make the cutting to make the asexual propagation. But if we look generally about most of the trees you can make the propagation or in seeds, or in sexual propagation or in asexual propagation. There are only few trees that they have, you can say the phrase, they have their eggs in the both baskets. That you can propagate them in seeds and also in asexual propagations. So you have to know your tree and to decide in which way you want to propagate it. And as I said before, in forestries, we prefer the working with seeds because you get genetic variation. Okay. So if we're talking about locating the mother tree, so how will I find the best tree in the forest, or the best tree that I want to take the seeds from this tree? So what is its mother plant? What is the best tree in the tree? So here in Israel, or actually in all over the world, if you don't have like a plot that you defined it as the best plot or something, if you look about a uniform area, but an area that it's all the same from the terms of environmental condition, and all the trees are look the same, but then one tree is from, you don't know for which reason, but is bigger or have something better in this tree. He is stand better from some bug or I don't know. So this tree is better for you. So it's good to take the seeds from this tree to take your seeds. What I mean, this is like a nice picture on nice draw that someone made for us. If you look for plot in the forest, and all the trees are pretty the same from the same species. And then for some reason, one of the tree is bigger or have some traits that are better than the other trees. So probably this tree have better genetics. And this is the reason we want to take the genetic of this tree to the next generation. So we will go to this tree and we will collect the fruit of this tree and we will take the seeds from this tree and we make new trees like this tree. This is an example of quality mother plant of Brutia pine in Ben Shemen forest here in Israel. All the plot is the same from environmental condition. All the trees are in the same height and look the same, but one tree in the corner is much bigger, much wider, much greener, and so on. So we want to take the cones and seeds from this tree. Another example, this is Quercus itabarensis in Park Sharon in Israel. And there are many, you can see here in the left side of the picture, there are many Quercuses, oaks here in the park, but there are 2 or 3 trees in the park that are much bigger than all other oaks in the park. We don't know really the reason, but all the park has the same environmental condition. So probably those tree has better genetic resource. So we will collect the seeds from those trees because we want this genetic resource, this genetic to go on to the next generation of our trees. Okay, of course, the trees we will take from the seeds, we look for trees that look healthy with no sign of disease or no other problems. And another thing that we must think about that when we take the seeds from the mother plant, we don't know really who pollinated them. And this is why it's so important to take the seeds from really good quality mother plant. Okay, and I think I actually answered this question. How do we separate the genetic traits from environmental influence? So we look for another option to look about this question is if we take place that it's very difficult place, that place that the environmental conditions are difficult, are bad, but the tree is looking good, so probably the tree has very good genetic traits, and we want to take the seeds from this tree. Or for example, if you have 2 trees and one is growing along the river and one is in the top of the hill, of course, I will want to take the seeds from the tree that grow on the top of the hill because this tree has no water, and the tree that growing along the river has water. So the tree that growing along the river, I don't know if this tree is big because it's genetics or because of the environmental condition. But the tree that grow on the hill probably is good because it's genetic traits. Okay, let's continue and give some example. Let's see this Acacia tortilis. or we call it Acacia radiana. This species is very drought resistant. It's a native species of Israel. It's grow in the desert of Israel, in desert area of Israel, very tolerant for drought, and most of the time, usually it's growth near to stream. Okay, but we look for trees that much far, okay, much far from the streams, and we took the seeds only from those trees. Because if we see trees that far from the streams and are still the trees look good, so we sure that those trees has very good genetic source. And we'll speak more about this in a few next slides. So we can see here the guys collect the seeds from this tree, and another nice tree of the Acacia radiana. Okay, so I think that in each country you have or in every place the qualities or the best tree it's something else or the elite tree. So here in Israel, the elite tree for us is we look for tree that is drought resistant tree because we have problem with water with rain. We have rain here in Israel something like 4 or 5 months in the year. The rain start something like in November, and the last rain is something like March or April. So actually, the tree has no rain, something like 8 months. Okay, nothing, even not drop of rain. So the trees must stand with drought for something like 8 months. So we must have a drought resistant trees. And the second trait we look for is trees that resistant to harsh soil condition, and the third is trees that are resistant to a disease or insect and so on. And this is the traits that we're looking for, and I'm sure that each one in his own country has its own traits that he is looking for in the tree forest. Okay. It can be also that in specific tree, you can look for specific traits. Like here in Israel, when we propagate, for example, a strawberry, we look for strawberry with sweet fruit. Because when we plant strawberry, and if we will not have sweet fruit, so what for we put the strawberry tree? And another example is the cypress. We have here in Israel a problem of fungi in the cypresses. So we collect only from cypresses that has some resistant to these fungi. So from some specific trees, sometimes you must have specific traits that you look for. Of course, this is something very important. We must remember that it's essential to match the habitat of the planting site to the collection site. It means that, and this is something that I think most of you know, that if you collect from the I don't know from the north of your country, so we must plant the trees that you make from those trees in the north, and if you collect seeds in the south, so the trees you make from these seeds, you must plant in the condition that look the same in the south, and so on. Because if not, you will make some genetic flow and so on, and probably the seeds that, for example, from the north, they have fitting. Okay, they fit to the condition in the place they came from, and if you will put them in another place, they will not fit to, and after they will not fit to the other condition, and after, I don't know, a few years or so on, they will not look good, or they will die, or even you can say that if you will take seeds from the same place, I'm sure they will grow better. So we can summarize that with time and experience, you will locate the mother plant with or plants that produce seeds from which you can produce quality plants. So until now, we spoke about and we answered the question about which tree do we want to collect from the seed. Now let's try to answer the question about where we will find those trees. I'm sorry, and when we should collect the seeds, all over the year or so on. So let's start with the answer about where. So here in Israel, we have some GIS application that each tree that we collect from, so we just mark it in the GIS. So actually, the collection is carried out, as I said before, all over the country. And how we find the tree is according to the knowledge that we have for many years. But you know, trees are dying, and we find from time to time new trees. So that's why I have to be, and we have to be in connection with people in the field all the time, because foresters and people in the fields are in connection with us, and they can tell us we find very big tree or very good tree that we think it's good, it will be good to collect tree seeds from it. And then I come with my employees and so on, and we see the tree and we decide if it's really good to collect seeds from it or not. And as I said before, each collection is marked in the GIS. As you can see here, each tree or trees or plot has a dot here in the map, and each place we collect, we take even a photo and recording notes on the collection and the condition of the tree and everything. So when I get to the tree, I can go to the past, and I can see all the information. And I have also in the app, I have a navigation, so I can navigate to the tree and get exactly to the tree where I collected last year. Here is another picture of the application. So this is just an example. I know it's all in Hebrew, so I hope you will believe me. But this is the name of the tree and who collected and when was the first collection, the last collection, who collected it, when was all the years that the collection was made. Is it one tree, few trees, plot of trees, how to get to the tree, which forest, the name of the tree in Latin, the family name of the tree, and so on. So we have a lot of knowledge, and as I said before, even we have picture of the tree and so on. So it's a lot of information about all the seeds and fruit collection. Now, what about when it's the right time to collect the fruits or the seeds? So after a long time of collection, we make we made a Gantt chart for collections, and we know actually here in the right side. Okay, this is all I know. It's really small letters, and it's also in Hebrew. So you have to believe me that it is all names of species, and for each species we know when it's the month that is the right month to go to the field and collect the seeds or collect the fruit actually. So we know for each tree when it's the right time to go out to the field. For example, now we are in May, so I know that here in May, those are the species that we should go out to the field and collect the fruit. And also here we have like small mark if the tree is kind of tree that we can storage the seeds of this tree, or if we must collect every year the seeds year after year after year from the beginning, because there is impossible to storage the seeds of this species. Now this is only the part of the chart, and this is the whole chart, but it's really big one, so I couldn't put it all in the presentation. So this is the chart, and from this chart, actually, we made an annual work plan. Okay, so if I know in which month I should collect which species, so I make annual work plan. I know this is January, February, March, April, May, June, July, and so on. So I know that here this is May, which species I should collect. This is species for forest. This is species that were ornamental, and so on. So I know exactly which species I should collect in which months, so I will not skip or miss no species. So I know now when, I know where, I know from which tree. Now we will talk just just a little bit about introduction and tree improvement, because today we have a lot of problem about climate change and decrease in precipitation, and we have heat waves and fires and pests and so on, and we want to have trees that can go over these problems. And the biggest problem we know about it, or we have it here, is the drought resistant, as I said before, and resistance to pest and disease. And one of the way we try to stand with and go over this problem is the introduction and the tree improvement. And introduction, that means that you bring new trees that are not native species. It's a little bit risky because you can have invasive species that mean you have to take care very much, and to see what you bring inside, and to look very good before you work with the species. But if you have a good tree that that go on and respond to the challenges, you won, and you have a good tree that can give you the answer to your problem. And I will give I will give an example. And tree improvement, it's mean that it's a process of like like it's not like creating a new plant. It's mean that you make in a process to find the best tree by making um, some options, something that you're doing by yourself. You're not just looking for the best tree in the tree. You doing some test and you're making some plots to find which tree will be the best to and which tree from the offspring will be actually in the fields will give us the best trees actually in the forest. And let's see the examples, and we will understand it the best. In Israel, as I said before, we have the species that called Acacia tortilis, or we call it Acacia radiana, and this is an example for the tree improvement. And as I said, it's grow most of them close to runoff water, and we found something like 30 trees that look really good that grow far from the runoff water. So we collected the seeds from those 30 trees that grows very far from the water, and we grow from them sprouts. We produce trees from them, and we planted them in one plot under very harsh condition. And then we saw that offsprings of 3 trees showed better development compared to seedlings derived from the other trees. So if it was just a regular seed collection, I should have collected from the 30 trees because they're all very far from water. But now I made a test and I saw that actually 3 trees has better offsprings, and their offsprings showed better development than the others. And this is, for example, of the mother plant, one of the 30 mother plant. And this is the trees that we planted in the examination plot. And after something 10 years, we saw that part of the mother plant looked not so good like in the left side. And part of them, as I said, 3 of them look much better like in the right side. So today we know that we collect only from those 3 mother quality mother plant because we know for sure that those 3 trees have very good or very quality offsprings. And this is another good picture. You can see that this offspring or this tree look much higher and much greener and much better there than this one and this one. And example for introduction, in Israel, we have a lot of eucalyptus. Eucalyptus, it's very good genus, and there are many species in this genus. In Israel, we tried many species, something like 150 species and even more. And we made many experiments about the eucalyptus resistant to limestone, resistant to drought, resistance, and species for big grazing, species for wood production, and so on. And of course, eucalyptus came from Australia. It's not native to Israel. It's not invasive, so we can plant it with no fear for invasive, and it's give us solution for places that we don't have the answer from native trees. And today we have here in Israel two books that we have from them all the information we need about the eucalyptuses in Israel, and what is the best use from each tree, and which tree is better for arid area and which tree is better for chalk soil or for salt or for, and what is the height of each tree, and if you want all the trees will flower in the same time, and so on. So we know all the traits of each tree and so on. So if you want to make plot of eucalyptuses, so you can choose which species you choose and to grow it in the nursery and then to plant it on the area. Okay, so let's back and continue with the fruit collection method. So how exactly in the area we collect the fruit? So we try to do it in the easier, in the simplest way we can do it. So if we speak about trees or shrub that are up to 4 meters, so of course the collection will be from the ground, with or without ladder. And I mean shrubs or a natural forest. For example, if we talk about the short oaks or a myrtle or a hawthorn more. So just to collect the fruit by hand. And if we will speak about 4 to 7 meters, what we are doing is just dropping the fruit by pole. And I speak about the various fruits and ornamental trees. For example, Cultiforum, if you know what I mean, jacaranda, walnut, juju, and more. Just drop the fruit by pole, and then you take them to the seed center, and you can work on the fruit. The more interesting work is when you get to trees that upper or higher than 7 meters, then the collection must be or by climbing or by, we will see how. Here, our team working with climbing. The climbing is by rope, because we don't want to make any damage to the tree. As I said, it's a mother plant tree. It's the best tree in the forest. We don't want to make any problem to the tree, any breaking of the branches or so on. So we have here an example of collecting cedar cones in the beery forest. You can see the guy here and the rope. Just collect all the cones here from the branches. There is also an option to cutting branch with the rope. So if you have all the fruit in the same branch and you want to take all the fruit in one time, and you say, okay, I will take the branch out for one time, you can throw the rope and to cut the branch. It's another option. We use it from time to time, but most of the time we climb on the tree. We make a course once a year, all the team and all my team, and we climb the tree. We became professional, and not it's not an easy work, but when you become professional, it's become not as difficult as it looked like. So let's see some nice picture here. We can see a collection of Atlantic cypress or Cupressus atlantica in Nir Etzion forest. It's near to Mount Carmel in the north of Israel. You can see that you can climb almost until the tip of the tree. And why to get so high? Because when you talk about conifers and the pollination is by wind, many times the cones in the high part of the tree have better pollination and the seed is in better quality in the higher part of the tree. Another great picture of collecting Himalaya cedar, again in the northern of Israel. You can see the guy here with the helmet and all the equipment and just collect the cones from the tree. And if you remember the Brutia pine picture from the start of the presentation, so now you can see this is me climbing on the tree to collect the cones from the tree. There is another option that is more easier and you can be less professional if you want to do it. It's like a ladder that you can put it on the trunk of the tree, like you can see here on the eucalyptus, or actually it's a Corymbia citrudora, and you can get on very high on the tree, and then just to take the pole and to cut some branches with fruit. The fruits go down, and then you can take the fruit and get the seeds outside. Okay, when we must uh, use a crane, we must use a crane when we have to work with many trees in the same day. For example, the picture in the right side, in this plot, we had to climb on something like 10 trees in the same day, and this is impossible. It's impossible to climb on so many trees in one day. So we hire a crane, and if you work on a crane, it's much expensive, of course. And of course, you don't, it's impossible to bring a crane to each spot or each plot in the forest and to climb, you can climb everywhere. But crane, it's impossible. But if you can bring the crane, so it's expensive, more expensive, but you can get to more trees and you can get to every spot in the forest, in the tree. And you can see here in the left picture, the Valechia elatior. This tree has it's very spiny, so it's really difficult to climb on. Okay, it's a very thorny tree, so it's impossible to climb on. So we have no option just to bring the crane and take all the pods from the tree and continue, even if it's more expensive. This is the only option. Okay, something that it's important when you collect the seeds. Sometimes people collect seeds and then after they bring all the seeds home, they understand that all the seeds they collected are empty or all the seeds are not good. So one of the first tests you have to do is called the cutting test. It's when you take something like 10 seeds and you just cut them with scissors or something, and you have to see the endosperm, that's most of the time is white, or the cotyledons that most of the times are green. And if you see very nice white or very nice green color, so you know that the seeds are good and you can continue with the collection. But if the seeds are empty and you just collect them in a shell, so there is no, just a waste of time to collect. What you do if there is, you take 10 seeds and half of them are empty and half of them are good. So it's depend. It's depend which species is it, and it's depend of how rare is the species and how much you need the seeds and so on. But it's give you a reflection of what the quality of the seeds that you collect. Okay, now we will continue with the topics, and we got to the extraction of the seeds from the fruit. So we must understand that the separation of the seeds from the fruit is going by some several principles, and this principles is something that is with separation with every material. We try to separate one from each other, and and we will speak about all of them now quickly, and then we will speak about each one, okay, more in different slide. And you can separate things by heat, and we using heat with by sun or by oven. You can separate things by size, and this is if you use sieves or strainers. You can separate things by weight, and this is you do by wind or by fan. And of course, you can use water if you're doing floating or softing. And of course, you can make cracking before all those separations. And I will explain it now. Okay, let's start, and I will explain it. If we will talk about heat, okay, the first way of separation two materials, or here we talk about the seeds from the fruit, we can use the heat. If you use heat in cones, the heat will open the cones, and then you can just shake the cones, and all the seeds will go out. You can use the heat to dry fruit if the fruit are wet or so on. This is something very important because when fruit or seeds are wet, they can even start germinate, or they can have fungi and so on. So we want all the time to work with dry fruit and seeds. And sometimes before you work with the fruit, you want to crush them or to crack them without damage the seeds. So we want to hard them. We want to make them more hard, and you put them in the oven. And of course, we put the oven until 50 degrees, because more than 50 degrees, so the seed will have damage. Okay, all the protein in the seeds will be damaged, and the seed will not germinate after it. Of course, if we want to separate the seeds from the fruit or from part of the fruits, we can use sieves or strainers. If, for example, we have seeds and chaffs, we can that are not in the same size, so we can separate them by sieves or strainers. As I said before, you can use it or before you crush them or after, if you have waste that collected in the field or after breaking the fruit. And there are many machines in the market for and that are actually kind of strainers that are shaking, and then you have separation by size. Okay, well, for example of this machine in the picture. And of course, there are many kinds of separation by hands. For example, this sieve that you can see here the pods of a carob tree, Serratonia seliqua, but you don't see the pods because we crushed the pods, and we have now parts of the pods and the seeds. And when we use the sieve, all the seeds will go down, all the parts of the pods will stay in the sieve, and we have eventually clean seeds. Of course, we can have separation by weight, and separation by weight is by wind or by fan, and you can do it very simply. We don't try to make it very complex. You can do it very simply if you just put or throw all the seeds and the chaff uh, in front of fan, and then all the chaff that is its weight is very low will just flow away, and all the seeds will go very close to the fan, and then you can have separation very easily. Of course, there are many machines more expensive, but for example, there are this vacuum seed aspirator. What this machine does is that it's make vacuum air from this area, in the right side, and the seeds go down here, and the vacuums just pull all the chaff and all the materials that are not the seeds, and then you have a separation between the seeds and all the chaff. And you can control about the power of the vacuum. So if you put too much vacuum, then you will also take the seeds here with the chaff. And if you have control and you put less vacuum, so you have the chaff here, but the system is closed. So if you have a mistake, you can do it again and again and again until you have clean seeds. Another machine that we have, it's called seed blower. We have here like a cup that in the bottom of the cup we have a net, so you can put the seeds with the chaff on the net, and then from the bottom there is like a tunnel of a wind, a very strong wind. So again, you can control the wind, and then all the chaff just going up to here, to those two cups, and here in the bottom, all the seeds, the clean seed stays here because they are more heavy. Of course, you control the amount of wind that's coming from here from down. And again, this is closed system. So if you make any mistake with too much wind or too less wind, you can do the process again and again and again until you have clean seeds in very short time. And of course, you can have work with water. The first work with water is to floating. If the seeds are empty, they will float. If they are full, they will sink. And if you have seeds or fruit that are fleshy, so we have like pears or myrtle or apple or juju, and we have work with special machine for this that's called a diving machine. This machine actually work like it has like plate in the bottom of the machine. It's look like in this picture, and the machine is, and the plate in the bottom is just going around very fast. And when you put the water inside, so all the fleshy part of the fruit is just smash on the wall of the machine very gently. very, very gently, very, very slowly, time by time by time, and then it's go from the upside of this plate. This is how I call it. It's like here you see all the fruit is just sitting on the plate, and in the upper side of the plate you have like here like a tunnel that all the fleshy part of the fruit can go out. So eventually, here you can see the plate. Eventually, you get clean seeds, and then you have like a door that you can take all the clean seeds outside. So this is a special machine for uh, fleshy fruit, and you can work with dates, pears, apples, you name it. All the fleshy fruits, you can work with this machine. As I said before, in most of the fruits, we start with the cracking. And to crack, there are also in the market many, many machines of cracking or breaking. And most of them are built from wheels. For example, this machine are built from two wheels that there is a gap between the wheels. And if you and you can adjust the gap between the wheels. And what we are doing is to adjust the gap that it will be bigger than the size of the seed. Okay, we take two, three, five seeds and we see that the gap is bigger than the seed. And then we can crack all the fruit, and then we can be sure that the seeds will not break in the machine because the gap is bigger than the side of the seed. We see here, for example, the carob tree or the Serratonia seliqua, and for eventually for each species, we need to find the principle and the appropriate sequence of action to extract the seeds from the fruit. And the Serratonia is a good example because if I will try to take the seeds from, I don't know, half a ton of Serratonia and I will do it by hand, it will take me months. But what we are doing is we take all the pods and we put it in the oven for 1 week, and then all the pods became very hardy. And then we crack all of them, and then we put all of them in the sieve, and then we separate them by wind, and then we have clean seeds. So you must find the sequence for every species, how to separate with all the machines you have, with all the equipment you have, how to separate the seeds from the fruit. And you have to remember that you can use water, wind, size, and weight, as I said before. And let's see some picture to summarize this part. For example, we have the Celsius siliquistrum. This is the tree, and those are the pods. And eventually, we have these seeds and the ziziphus that we saw many pictures from those fruits and seeds. This is the tree, very drought resistant tree here in Israel. It has like small apples, and when we clean it, we can see the seeds. It's not actually the seeds. We should break it, and then inside, in each one of these balls, there are two seeds. But we must keep it in the refrigerator room in this way, because if we break it, we must bring it to the nursery and try it in the same day. And another example is the myrtus. The myrtus has very small seeds, also fleshy fruit. the Serratonia siliqua, also very drought resistant tree, has very hard pods. You can see the seeds. Oaks, Quercus ithamorensis, and the Quercus coctifera. In oaks, there is no machine. Everything is by hand. You collect it by hand and you separate it by hand. No machine to help you with those species. Eucalyptus is a very big tree, but the fruit is very small and the seeds are much smaller, like a dust. But still, we need to work with if we want to have a tree for the next generation. You can see here how big the tree is. You can see the car here. And also the Corymbia citrodora. In this eucalyptus, the seeds are a little bit bigger, 5 millimeter. Okay, so until now, we talked about the propagation from seeds and the location of the mother trees and a little bit about the introduction, the tree improvement, the fruit collection method, the extraction. And now we will speak about seed storage. And we still have the pre-germination and the germination methods. Okay, let's continue. Seed storage. So the initial stage before the storage is I want to know how many seeds I have. Okay, because I want to know how many seeds I put inside the refrigerator room. So the number of the seeds will be obtained according to the ratio between the number of the seeds and the seeds weight. You see here the box with the seeds of the Serratonia. How many seeds there are in the box? So I will weight all the seeds. I will weight 100 gram. I will count how many seeds I have in 100 gram, and then I will know, okay, I will make the calculation and I will know how many seeds I have in all the box. Let's do an example. For example, if I have 1 kilogram of seeds and I have 1,000 seeds in 50 gram, who have here a quick thought and can make the calculation how many seeds I have? Okay, I have in total 20,000 seeds. Okay, if I have 1,000 seeds in 50 grams, so in 100 gram I have 2,000, and in 1 kilogram 20,000 seeds. Okay, was it clear? שני, שומעים אותי?
Yeah.
שני?
Audience is quiet.
Okay. Okay, after I know the number of seeds, of course, I weight, as I said before, the amount of the seeds, and of course I weight each collection differently. You can see here example of weighting seeds of Pistacia atlantica. And then I will put the seeds in the refrigerator room. Or I will take the seeds and will sown them immediately, or to store them in cold temperature and low humidity. Why cold temperature and low humidity? Cold temperature is to keep the seeds alive. Okay, I want them to be alive and I want them to be in low activity. So this is why I want cold temperature, and cold temperature is something like 4 degrees. And because I want to prevent fungi and other problem, with the seeds. That's why I take the humidity down to something like 30, or if I can make it even less, to 30%. Okay, the humidity. As you can see here in the picture, here it's 4.8 and 35% of humidity. This is quite good condition for storage. Okay, and as I said, if the seeds are moist, even if I state that the seeds are moist, so even before I will put them in the refrigerator room, I will try to dry them and not to put them in the refrigerator room when they have some moist, because they will really fast will have fungal and other problems. You can see here in the picture that we have here some antenna, and the antenna just sent to my phone all the time all the data here about the temperature and the humidity in the refrigerator room. And this is what I can see in my phone. Okay, so I have a remote monitoring, and I can see the temperature all the time, and I can see the humidity all the time. And if there is any problem, so the system will send me alarm that the temperature is too high or the humidity is too high, and then I know that there is problem in the refrigerator room. So there will not be any case that I will not check the refrigerator room for too long, and it will be any problem. Okay, before I put the seeds in the refrigerator room, before I store them, I must record all the information to the computer. We have software that control all the information about the seeds, which species, what we collected, where we collected, and so on. The same as we have in the phone about the collections. We have it the same in the computer, but in the computer we put also what exactly we had in the final process, how many seeds, what the weight, and how many seeds in 100 gram, and so on. And then we take from the printer sticker with the collection location, with the collection date, the date of entry into the storage room, and we put it on the bag that we put the seeds inside, and then we can put the seeds in the refrigerator room. This is an example. This is Brutia pine, and the date of the collection, and the amount of seeds, where it was collected, and when we put it in the refrigerator room, and which shelf in the refrigerator room, so on. Okay, this is a picture of the cold storage room for the seeds preservation. And from here, of course, we send the seeds to the nursery for germination. Okay, now let's speak a little bit about pre-germination treatment, because this is something really important. It's really necessary to understand it, that if you want to germinate your seed, you must have essential seed. The seed must be a good seed, and you must have water. You must have temperature that fit to your seed. You must have air, and in some species, in some seeds, you must have light. Not in all of them. There are many seeds that you can germinate in dark. That's why it's not in all species. And the seeds, if you want that the seed will germinate, the seeds should not be dormant. Okay? If you have all this condition and everything is okay, the seeds is essential and you gave the seed water, temperature, and air, and you don't have germination, probably you have dormancy. This is an example for the need of or the effect of temperature on the germination process of Aleppo pine or the Pinus latensis. You can see that if you germinate it this is the days, you can see in the X and in the Y is the germination percentage. You can see that if we germinate it in low temperature of 15 degrees, okay, the percentage of germination is very low. And in 25 germination, it's also very low. But in only 5 degrees of different, in 20 degrees, the germination percentage is going up to close to 80%. So this is an example of how much the condition and here, for example, the germination, but the condition of germination is so important. But if we go back to the
Just to say, we have 10 more minutes and we want to have time for questions. So
just 10 more minutes. Wow, I have so much more. So if we have only 10 more minutes, so I will do it much quickly. So
maybe one idea. Maybe we can. I don't know if we have a lot of more information. Maybe we can do a little break now, or when you decide.
I will
we
do
ask.
it. Okay.
We can answer some questions.
Evelyn, I think I will do it in 10 minutes and it will be okay.
Well, we can give you another 5 minutes. We can say 15 minutes, okay?
Okay, it's okay. Okay, thank you. Okay, let's talk about the dormancy types. Actually, there are two. We can divide it to two types of dormancy. One, we call it the physical dormancy, and the dormancy is resulting from the physical or biochemical factors present in the tissue that surround the embryo, not inside the embryo, or physiological dormancy that cause from something or physiological factors inside the embryo, okay? Physical dormancy from outside and physiological dormancy from inside the embryo. And how we solve this dormancy types, okay? How we break the dormancy. So if we talk about the physical dormancy, okay, from outside, okay, so we should make some damage to the seed coat by mechanical power or by hot water or even by acid. Okay, let's see an example. Here we have, for example, just a minute. Here we have Rubinia pseudoacacia, okay? And we can see that if we make some, just in control, we just put the seed in the water, 10% of germination, hot water, 35% of germination. But if we use scarification for the seeds, or we use the sulfuric acid, so the percentage of germination is going much higher, close to 70%. Okay, so we see that if we make any injury, okay, to the seed coat, so the germination is going up. In our example, okay, retema, okay, it's desert shrub, very drought resistant. We use in Israel in planting in the arid area. We tried it in tap water and in hot water, and you tried it also in sulfuric acid. And we can see that only after 3 hours of sulfuric acid, the germination percentage go up to something like 50%, okay, 50%. But you will ask why we didn't try 4 hours. So I can tell you that we tried 4 hours, and after 4 hours, the percentage go down. Okay, so we know today that 3 hours is the maximum, and we get something like 50% of germination. But of course, if someone will try to germinate it only with water, with tap water, you will get almost no germination. And this is the ratema. You can see the tap water with no germination and sulfuric acid 3 hours, beautiful germination of the seeds. Another machine that we have is the scarification machine. This is a very small but very strong machine that we can put the seed here inside and put the sandpaper, and then there are some like wings that rotate the seeds inside on the sandpaper, and then you just make like small injuries in the shell of the seed, and then water can get inside and actually you break the physical dormancy. Now, if we want to break the physiological dormancy from inside of the seed, so what we are doing is called stratification, okay? That means we put the seed in cold temperature and high humidity for long period. Long period can be between 14 and 90 days. It depends in the species. There are species that for a long time, there are species for a short time. And this is a picture how it's look like. We put the seed in some media, for example, vermiculite. It can be perlite. It can be sand, and we just put it in wet vermiculite. Put it in a bag. Put some hole in the bag so it will not be too wet, and the water can go down. And we put the moisture once a week. And you can see that after few weeks, the seed start to germinate, or we bring the seeds to the nursery and the seeds germinate in the nursery. So we can summarize that we can break, and this is another picture of the stratification, and we can break a physiological dormancy by stratification, or physical by scarification with the sulfuric acid. This slide can summarize, I think, most of this presentation. If someone here, I don't know, went to the bathroom or so on, you can see this slide and you can see here most of the presentation, because actually this is what we are doing. This is the life cycle of a forestry seed. We're locating plus seed trees in the forest. Then we collect the fruit or the seed, okay, from the tree. Then we extract and separate the seed from the fruit. We clean the seed, we sort them, weight them, count them, so we know how many seeds we have. Then we store them under control condition, 4 degrees and 30% of humidity, and then we transfer the seeds to the nurseries, and the nurseries germinate them, and then we have the best trees for the next generation. And sometimes we take the seeds from or straight from the counting or from the storage room and make them pre-germination treatment and send them to the nursery. And this is the life cycle of the forest reseed, and this is summarized most of the presentation. Let's continue and really quick about germination. When we bring the seeds to the nursery, they're germinated in humid areas, sometimes in germination boxes, and sometimes straight to the final container. It depends of the species. And this now I will show you some pictures about germinated boxes. This is Pistacia lenticus sprouts. It's all trees and shrubs of the Mediterranean area. Celsis australis, and this is the Amygdalus communis. Here the way we work is in most of the species we germinate in boxes, and then we transplanted it to the final box or into the final growing container, and then we have full growing container, because if you sow it straight to the final growing container, you must have seeds with very high germination percentage. Because if you don't have it, you will have many empty holes of seeds that did not germinate. Okay, so this is how the workers germinate the sprouts to the tries. And you can see even here. I don't know why the film is not working. Maybe now. Okay, and this is Acacia tortilis sprouts that the workers are transplanting. Okay, that's also a very drought-resistant desert species. Okay, and this is what we have after this transplanting, and after 2 months, and okay, and of course, very important to stay them in the shade for even I think something like 2 or 4 months until they will establish and develop. And this is a picture, something like after a year. Of course, we have also a vegetative propagation. If you still remember the start of my presentation. This is, for example, Tamarix aphilia after 5 weeks. And you can see here very nice rooting of Murus alba, okay? And you can see already the fruits, okay? Because it's not juvenile if you make the rooting, so you get immediately an old tree. Of course, we have the rooting table in the nursery, because if you want to make very good rooting, so you must have foggers and you must have the good temperature in the root table. And we can also talk for an hour at least, or in a different presentation about containers and in which container to grow the trees. But eventually, what we want is to have high quality root system, and we don't want to have circling, because if you have circling in the root, you will have after a few years a lot of problem in the tree, and after 5, 6, 10 years, then the tree die from reason you will not know, and in many times it's because of problems in the roots that you had the problem, you had the option to prevent if the root system was built in good in good way. So if you have a good container and you have a good root system, so you start with building good sprout and good tree. That's all. I hope you enjoyed, and I hope you learned. And now the time for question. And thank you very much, you all.
Thank you very much, Hagay. I think we have a few questions already in the chat, but maybe if you have questions and you want to ask them, you can wave your hand.
Maybe you stop sharing, Hagay, please.
Okay.
So someone asked about, Rene asked about after the pre-germination treatment, do you check the germination rate of the seed?
Yes.
Yes.
So
It's a personal information. Thank you very much.
okay. So after the treatment that we're doing to the seeds to break the dormancy, and we send the seeds to the nursery, we must be in connection with the nursery manager and to see if everything works as we want. Okay, if the germination ratio is good or not good, and so on. Because in seeds from this year, the treatment works good, and seeds from another collection works little little better, or sometimes less good. And so eventually we must be in connection with the nursery manager and to see what was eventually the germination ratio.
Yes, my question is a bit more precise. When you do, I've seen some pictures about the germination, right, with the germs coming out from the seeds and everything. But are you doing an analysis of the germination rate? Is it 70, 80, 90%, 95? Where in Israel, generally the germination rate is quite high. But to have the best result, if you have a high germination rate of a seed, of course you have a better plant.
No.
So my question is, are you doing an
No,
analysis to know the germination rate of the seeds?
I mean, we don't check the germination ratio of each source of seeds. Because if I have, for example, a very good source of seeds, but the germination ratio is low, what do you think? I will stay with this source or not? Of course I will stay, because even if the source is germinated low, but the source is good, I will have few trees, okay, because the germination ratio is low, but the trees that I will get are very strong, okay. It's better for me than trees that have very high germination ratio, but the trees are weak, okay. So what I need to get eventually, is good trees. I don't care about germination ratio. I care about eventually to have enough tree that are in good quality.
Okay, and I understand, because it's not only the germination rate, but also the SVI is very important of the seed. If it's higher, if it's high, of course it will. The seed is more efficient, more strong.
Of course, it will be the best if it will be a very tolerant tree and very high drought resistant tree, and the germination ratio will be high, of course, but it's not all the time like this. If it is,
I understand.
it's the best.
It's just
yeah.
Okay. Thank you very much, Hagay.
You're welcome.
We had a question about specific species, Afcelia africana, if it could be propagated asexually.
I don't know this species, but you can send it to me by email, and I can check it. Today there is a lot of knowledge in the web, and also if there is relative species that we work with, I can get the information and give you the information about how and when and so on.
Another question is, how can we identify whether dormancy or chemical or physical in powder to give it the appropriate treatment?
As I said in the presentation, if you give all the conditions that the seed need, I mean water and air and proper right temperature, probably the seed is in dormancy. Now, then you have to know which kind of dormancy is physically or physiologically. Which kind you have to check in the web and so on, or in the literature, but you can have clue by the way that the seed look like. Most of the time, when the seed is very hard, it has very hard shell. It's physically dormancy, but it's a little bit tricky because there are many seeds that are very hard and they have like very small hole inside. For example, almond. Almond have very hard shell, but it has no dormancy. So the water can get inside very easily. So actually, you must check in the literature or in the web, and you can find most of the information.
I think Fabrice, you had a question? Are you still interested in asking? No, we lost him. Which are the most demanded species in the region? And which markets are the primary destinate?
I think the tree that we, if I understand the question, which tree we produce the most in our nursery? Today it's the Ceratonia seliqua and the Quartus itzabuensis. Both of them we produce something like 25,000 of each one of them each year, something like.
You?
Sorry.
Yeah.
Shani.
Hi.
Go ahead.
It was a network case. Thank you, Hagay, for sharing us this informative presentation. I've been following this session since they officially opening this, and it was really exciting to be seeing how Israel is combating with this climate crisis that the whole world we are facing. It's really exciting. So from this, I want to ask, because like when these African countries, as a developing countries, they are facing the problem of the nursery problems of they put the seeds into the nursery, they try to maintain it, and after all, like they find it, they fail to be getting the yard as they wish. And I want to ask, what is really measures? What can we do as African people? Basically, I'm in Rwanda. I work for Kilimo Trust. It's a regional NGO that's working for agribusiness, animal and livestock related services. So I want to know, what can we do? Because we are capacitating young people, we are capacitating the people about agriculture. What can we do? What can we teach the people to do in their nursery so that they can be making sure that their staff, their nurseries are being well equipped, and they're going to be serving as much as they put, as much as the money or as much as the effort they put, they're going to be getting it out. Thank you. I don't know if like my point is well understood with Hagay.
No,
Thank you.
if you can I first of all, thank you for hearing my presentation. But
Yeah.
if you can
Yes.
summarize your question, what you're looking
Yes.
actually for your people.
What I want to know is like, what can we do? What the measures to address that case of like putting much effort in seedling, in nurturing the trees, yet when we are going back to be getting those trees, mature trees are being like, they are being like the harvest of that that plant. You see, we're having a lot of nurseries, and we are putting much effort in treating the trees to be growing well. And then after all, like we find that we plant, like the seedling was about 100, yet we are going to get the mature trees to be planted. We are finding that almost 50% are being destroyed and not where to be planted. What are measures? What can we do here?
Okay. You must understand, you talk about that you planted the trees and then you not succeed after that, actually. So
Yes.
you must understand that planting trees and succeed with getting actually mature trees, it's a whole process. And
Yes.
what I talked about is just the first stage. As I said at my start in the start of my presentation, the first stage is to work with good source and to start with good source and to have good tree and to plant a
Yes.
good tree. But the second stage is to plant it properly and to maintain it properly and to take care about it, okay, and to irrigate it if you need, and to defend it from livestock if it's needed, and so on. So there are many stages from seed to mature forest. What I
Yes.
spoke about, it's only the first stage. There are, I think, Gil Siaki will one of my colleagues here in the KKL will speak about or spoke about. I don't know.
Yeah, spoke about last week.
Spoke about last week
Yes.
about other stages about how to maintain trees in drylands and so on. So there are many stages, and in each one you must in drylands. In each one, you must be professional if you want to have trees and forest in our world in the time of the changing the climate.
Okay, thank you, Hagay.
You're welcome.
Yeah.
Thank you.
Lastly, is it possible to be getting some seeds? I mean, to export, like to be to be exporting the trees, that's seeds, because like we are dealing with the trust where like we are getting the seeds. Is it possible like to be negotiating or to be requesting the seeds from Israel, like to be planted somewhere when we, is it possible?
Actually, there is possible to import or to bring the seeds from one country to another country, but it's really complicated because you must stand in all the rules of the Ministry of Agriculture and so on. So it's not easy. But as I said in my presentation, it's better for you to collect the seeds in your country and to plant them in your country, as the same that for me it's better to collect seeds in Israel and plant the trees in Israel than to bring seeds from Rwanda and plant them in Israel, because the seeds from Israel are more fit to the environmental condition than seeds that will come from Rwanda.
Thank you, Hagay.
You're welcome.
Yeah.
Evelyn, do we have time for more questions? What do you say? You're mute.
Well, it depends on the time of our friends, but I think there is maybe an interesting question here from Mexico. Did you see that? Is the app to locate mother plants available for public information?
Hagay, did you hear the question?
No,
Is the
I
app
didn't
for
hear.
collecting the locations is available? I think it's a self-made, right?
Yeah, it's self-made here in Israel, and Shani, we have to check here in KKL if it's possible to transit to others, but I know we build it here in our company. It's not something you can
Non-commercial.
yeah, it's not commercial. It's not something you can get it in your phones.
Okay, thank you. I don't know if you see any of the questions interesting for everybody.
The question about ratio between native species and introduced species.
Okay, so actually the amount of sprout seedlings we produce in the nursery is of course according to the planting plans. And we try to plant in the field as much as possible the native trees of Israel. Only in areas, in places that there is no option to plant native species, so we put trees that are not native, as I mentioned, the eucalyptuses and so on. Most of them in the arid area. In the Mediterranean area, I think that close to 80% of the trees are native to Israel.
Thank you. I think we will finish here. You think, Shani?
Sure.
Yeah, Shani, if you want to say some
Summarize.
closing words.
Yeah. Thank you very much, Hagay. That was a very informative and important lecture. I hope you all managed to follow and got more knowledge about all the subject of seed collections and germination and propagation. Yeah, and we will meet next week with Michael Sprintzin about technology and remote sensing. I don't remember the exact name of the lecture. And I think that is it.
I'll tell you, GIS and advanced monitoring systems in the Israeli forests.
Yeah.
Well, I would also like to say thank you so much, Hagay and Shani, yeah, for sharing all your experience. And as we said at the beginning, you are bringing a bit of hope because you are dealing with seeds, and that's the idea, to put new seeds in the in the soil in order to create new forests. And I think this is hope, yeah, for a better and greener world. So thank you everybody for being here with us. Again, we have a wonderful, great international group. We were today something like 70 people here together. Some of them already had to leave, but again, in the chat, please, you have the link for the playlist where you can find already our 2 previous meetings, and the third one will be in the next days, maybe tomorrow already. Okay, so with this, let's wish you a good night for some of you and a good day for some of you also there in South America. And yeah, see you next week, next Tuesday, 3:30 Israeli time here in the Zoom. So wishing you all the best and shalom from Israel.
Bye. Thank you very much.
Thank you for Honduras. Thank you for your attention. Good luck. Very nice whenever.
Bye.
Thank you very much for